Hi guys, in this video I'm going to be showing you how to do the chi-square test for the difference between proportions in independent samples using Excel. And so I've kind of set up a template here while I was working with one of my students, where basically all you need to do is input the gray areas and your final result is given to you in the form of accepting or rejecting the null hypothesis. Null hypothesis here being that the proportion from group 1, in our case group A, is equal to proportion of group B, is equal to proportion of group C, is equal to proportion of group D. And I've set it up for 4 groups just because you could do it for more. Typically these problems run between 2 to 4 groups. There's many situations where it could be much more, but this was just to keep it a little simple and not too simple. Okay, so you can use it for 2 groups, 3 groups, or 4 groups, and the template is built so that it can leaving these cells empty, because I've built in some recalcitrants here, some formulas that take care of errors. And basically you get not only a p-value that will compare to your alpha level, but also an exception or rejection based on the size of your p-value compared to the significance of your test, the level of significance, as well as comparing your chi-square statistic to the critical value. So let's just run through it. So this is our observed table. It's a 2x2 table, and group A responded 1 82 times, group A responded 2 118 times, group B responded 1 104 times, group B responded 2 96 times. Here are the column totals and here are the row totals. Now here we create an expected table, and the way you create an expected table is you take for each respective cell. So for example, for this cell, that's what we're talking about, you take its row total multiplied by its column total, so these two multiplied, and then divide that by the grand total. So this number 93 is 186, the row total, times the column total, and you take this from the observed table, divided by the grand total, and then you get 93. And the same thing runs for any others, and we could just choose this one for one more example. So we would take the row total for B2, B's that responded 2, and the column total, multiply those two and divide by 400, and we'll get 107. So we'll get 214 times 200. So you guys got to make sure you get the right row and the right column total for each cell that you're doing this for. And the grand total is always going to be 400. It's always going to be the same. Okay, and you get what's called the expected table, which is this guy right here. So we start with observed. This is what you actually observed in your survey. This is what you would have expected if the 2 groups were equivalent. In other words, if the null hypothesis was true, you would expect these results, specifically these results, if they were the same. Now what you're doing here is you're comparing what you actually observed to what would be expected if the groups were the same. And if what you observed and what you expected, if they were the same, are different, significantly different from each other, in other words, if this table and this table are significantly different than each other, then we will reject HO, and we would conclude that the proportions are not equivalent to each other, that there's at least one inequality. That's what ALOI stands for. Okay, so let's see what happens. We take each observed, O stands for observed, E stands for expected. We take each observed, so we take this and we subtract from it 93, and we get negative 11. Then we subtract 118 from 107, and we get positive 11. Then we subtract 104 from 93, and we get positive 11. And then finally 96 subtracted by 107, we get negative 11. Then we square each of these numbers. So we get, squaring makes them positive, and they're all 11, so 121. Then we take that number, 121, and we divide it by each one's expected. So this one was 93, so divide this by 93. This one was this guy right here, so 107. That's a divided by. This one here was this cell, B, group B, response 1, so that was 93. Remember, we're taking the expected, and that's why I've made these headings over here, so you can follow what I did. 93, and finally, this cell, group B, response 2, 107, okay? And we get this column, okay? The reason why these are blank is because this is for examples that had more groups in them. We just had 2 groups in our example, so these will be blank. So you can disregard those. And finally, what I did here is I said if error, which is a formula in Excel, which will give you, if a value is an error, it will just return whatever you want it to return. So I said if this cell is an error, then give me this number 0. Don't give me, I don't want an error message, because I can't add these numbers up, and that's what I want to do. I want to sum up these guys. As long as I have these errors here, it'll give me an error when I try to do the sum function here. Okay, so I had to make this extra column here, which just takes this number and checks if it's an error. If it's not an error, it just gives me back the exact same number. That's why these are all the same. All these guys are the same, right? This is equal to that, that's equal to that, that's equal to that, that's equal to that. Just this becomes 0 instead of an error message. So that's what the if error does. Then over here, I am just summing this entire column. And since these are now 0, I can do that. Okay? So that was the reason for this column. So basically this was sum of all those. And this is my chi-square statistic. And I referenced that here. So this goes up here. Okay? That's our test's chi-square statistic. Then we get the chi-square critical either by looking on your table in the back of your textbook or using the Excel function chi-inv. That's C-H-I-I-N-V with degrees of freedom and your alpha. So first you put your alpha for your test, and every question will give you the level of significance. That's something you input. So this gray cells are all cells that you have to input from the problem. So usually alpha is 0.05. So the first argument of the chi-inv function is the alpha, and that's cell J7. And the second is your degrees of freedom. Okay? And that'll give you the chi-square critical value. By the way, to get the degrees of freedom, you take the number of rows minus 1 and the number of columns minus 1, and you multiply those two numbers. So since we had 2 columns, so 2 minus 1 is 1, and we had 2 rows, 2 minus 1 is 1, so it becomes 1 times 1. And that's what I've done here. I've counted the number of rows minus 1, and I've multiply that by the count of the number of columns minus 1. Okay? And so this chi-square critical value is basically, if I were to draw the curve of chi-square, it's a positive density function, which looks like this. And the critical value, 3.84, is somewhere here. And this means that any number more than this would be significant, and we would reject the null hypothesis. So our number is in the rejection region, right? So we would reject, and that's what we got here, reject. Okay? Now another way to do the same, come to the same exact conclusion, is to get the p-value for a test. And the way to do that is using an Excel function called chi-dist, C-H-I-D-I-S-T. The first argument is our chi-square statistic, which is this guy, which I've also rewritten here. And the second argument is the degrees of freedom, which we've gone through here. And that will give us the p-value for our test. And as we know, if our p-value is less than our alpha, then we reject HO, which is just another way of coming to the same conclusion that we came to up here. Okay, so there was two ways to do the same problem, and a lot of textbook questions will want you to do one way one time and another way another time, or both ways. So it's good to know both ways. Okay, so I hope this was helpful. Be sure to check out my other Excel, Access, PowerPoint, math, statistics, and other computer tricks videos on my website, Jalayer Academy on YouTube. Subscribe to my channel, comment, and be sure to click on our sponsors' ads. That's what keeps these videos coming to you for free. Until next time, have a great day.